All right, moving on to profit. So profit has a relationship between our revenue and our cost. Profit is going to be what we are able to create after we've paid off our cost. Revenue minus cost. The amount of money coming in from the demand of the product, commodity, minus our cost to produce those commodities will give us our profit. So revenue minus cost is our profit. Revenue was the price times X minus our cost. So marginal profit is going to be the derivative of our profit, how much we expect to have earned the profit for one more additional sale. Okay. So coming up to the profit function, we need to come up with, well, we need to remember revenue minus cost. And reminded us what the cost function is, revenue. And I believe revenue was negative 0.02 x squared and then plus 400x when we were dealing with these speakers. So that was from the last video. So this is the revenue and then minus our cost function. Let me let them do that for us. So our revenue and then subtract off our cost will give us our profit. And putting these two polynomials together, making sure to use the parentheses. That's going to be extremely important. So make sure the negative is distributed to both the terms. And I don't want to erase the slide. I want to move forward. And so our profit function is this quadratic facing down. Okay. Marginal profit. Marginal, I want to find the rate of change of how quickly the profit is changing per item. Taking the derivative, let me move it back. Taking the derivative of this polynomial using the constant multiple term. I'm going to write my constant. I'm going to take the derivative of x squared using the power rule. I'm going to add that because I can add two derivatives together. And using the constant multiple rule, the derivative of x in the first is just 1. And then minus the derivative of a constant is 0. So we should see negative 0.04 x plus 300 for our marginal profit. Alright, so the marginal profit, when we have produced 2,000 units, is going to be plugging in 2,000 into our profit function, our marginal profit function, excuse me. And so when we realize the sale of the 201st item, then we are approximately, remember it's not exact, because the profit would actually be the profit made on the 201st minus the profit of the 200th item. So this would be the actual profit versus the approximate that is given to us by the marginal profit function. Let me put in 2,000 here. That profit function that we are graphing was a negative 0.04 x squared plus 300. And so I might be missing that one. Let's see. Yep, I got that. That's the derivative. What is the actual function? Go back. There it is. Negative 0.02 and then plus. That makes sense. Keep going. Keep going. All right. Erase. What am I graphing here? The profit function was a negative 0.02 x squared and then plus 300x and then minus 200. So I see that the intercept here is minus 200 when x is 0. Profit in the hole, okay? You're not in the black, you're in the red at 0 items. Once you start selling these items, then your profit starts to increase, and you're going to have a maximum profit when that rate of change is 0. The rate of change is positive. You're increasing your profit for the sale of items all the way through, and marked in thousands, 8,000 units of speakers. After that, you notice that the profit starts to decrease. Okay?